Welcome to Solving Equations Quadratic in Form. Let me apologize in advance. There's somebody mowing the lawn next door, but I'm kind of in a time bind here and don't have any choice but to try to make the podcast now. So I'm going to do the best that I can. The general form of a quadratic equation is given at the top, ax squared plus bx plus c equals 0. There are a lot of equations, however, which do not look exactly like this, but they're close enough to this that we can still use the methods for solving quadratic equations to get answers to them using something called a U substitution. And if you take a close look at this, x just represents a number. So if it's in the form of a times any number squared plus b times any number plus c equals 0, that's still the form of a quadratic equation. For example, in this equation, the bases are the same. Now I say any number, but they have to be the same number. Here this was an x and this was also an x. In this one, this is an x and this is also an x, so the variable parts are the same. And what's important about quadratic in form here is that exponent is 1 and that one is 2. That is, it's important that the exponent of the higher power be twice as big as the lower power. So here, this exponent is -1, this one is -2. That's exactly twice -1. So this would be considered quadratic in form, even though it's not exactly looking like a quadratic equation. If we look at this next one, we said that x could be the number here that is squared and to the 1 power here can be any number. It doesn't have to be something as simple as x. It could be something like x minus 1 over x or something even more horrible than that. And I still have that the power here is 1. The power here is twice this power, and the x parts are the same. They're ugly, but they're the same. So this is still considered quadratic in form. In the third one, again, I have kind of an ugly x part, but they are the same. Both of them are x minus 2. This exponent is 1/3. This exponent is twice as big, 2/3. So that's still quadratic in form. What's most important is that the base numbers be the same. If this one is x, this one is x. If this one is x minus 2, this one is x minus 2. And that this power be twice as high as this power. And that this simply be a constant term here. Now, let's take a look at how we handle equation that's quadratic in form. First off, take a look at example 1 and notice that it is quadratic in form. The variable part here is x and the variable part here is x. And this exponent is twice as big as this exponent. But how do we use the methods of quadratic equations? Well, we use something called a U substitution. We'll say let U be x squared. We'll pick the variable part of the lower power term. Then we can say U squared is x squared squared, which is x to the 4th, which is exactly our first term. So our first term could be written x to the 4th, but since x to the 4th is the same as u squared, our first term could be read u squared. Since u is x squared, we can call this minus 4u plus 3 equals 0. Now that factors very, very simply. That's u minus 3 times u minus 1 is 0, which gives you the two answers, u equals 3 and u equals 1. But before I box that and say that that's the answer, let me point something out. There weren't any u's in the problem we were asked to solve. We made up the u. So if I give 3 and 1 as the answer, I'm not answering the original question. My answer has to be something in x. Well, if u equals 3, and if u is equal to x squared, that tells me x squared is equal to 3. And by the square root property, that tells me x is equal to positive or negative the square root of 3. If u is 1, That tells me x squared is 1. So again, by the square root property, x is equal to positive or negative the square root of 1, which is positive or negative 1. Now, because we are playing with those exponents, we do have to check and make sure that our numbers work. Go ahead and check in positive 1, negative 1, positive square root of 3, and negative square root of 3, and verify that they work. By the way, if you want to do something like square root of 3 to the 4th, just do square root of 3 squared times square root of 3 squared, and you get 3 times 3, which is 9. So you end up in your original equation with 9 minus 4 times 3, which is minus 12, plus 3 is 0. That's true. So the square root of 3 checks out. Turns out that the negative square root of 3 checks out, and both these answers check out, but you do have to check them. You get 4 answers, positive and negative 1, and positive and negative square root of 3.